The James Webb Space Telescope has recently captured something truly astonishing. Lights that appear to glow like a city from a point in space about 4 light-years away. This unexpected observation has reignited global interest in the search for extraterrestrial life. The telescope was specifically focused on Proxima Centauri b, the closest known exoplanet to our solar system, where it detected strange, bright flashes. These flickers of light have led to widespread speculation. Could they be evidence of an alien civilization? For decades, both scientists and the general public have been fascinated by the idea of life beyond Earth. Any scientific hint pointing to something out there has always stirred excitement and hope. Now, the James Webb Telescope has delivered one of the most compelling indications yet, evidence that might suggest intelligent life exists somewhere in the cosmos. As it scanned the vastness of space, it picked up unusual light activity on Proxima Centauri b that resembles artificial city lights, a discovery that has captured the imagination of the scientific community. This could be one of the breakthroughs researchers have long anticipated, hinting at the possibility of organized, intelligent societies beyond Earth. These distant lights, located an incredible 4 light-years away, have left NASA engineers in awe. They wonder how long such phenomena have been occurring, invisible to us until our technology reached the point of being able to detect them. David Kipping, an astronomer from Columbia University, described Proxima Centauri b as a particularly complex planet. Unlike most rocky worlds that absorb sunlight and emit energy in infrared, this exoplanet displays different behavior, largely due to its unique relationship with its star, Proxima Centauri. The discovery highlights just how vital the James Webb Telescope has become in space exploration. Its sensitivity to infrared wavelengths played a crucial role in spotting the odd patterns on Proxima b, patterns that could tell us more about the planet's atmosphere and surface characteristics. Scientists plan to use the telescope's capabilities to study the exoplanet in greater detail, even to assess whether it might be habitable. Because the telescope is especially good at detecting faint light in the darkness of space, it's an ideal instrument to determine whether the city-like lights observed on Proxima b's dark side are genuine signs of artificial structures. What makes this even more intriguing is that the telescope can detect artificial light sources within a narrow frequency range, much narrower than the natural emissions from stars. This makes it possible to pick out potential technological signals from the noise of space. Proxima Centauri b, like Earth, goes through a day-night cycle as it orbits its star. The planet also faces extreme temperature fluctuations that depend heavily on whether or not it has an atmosphere. Without one, the side facing the star would become intensely hot, while the opposite side would drop to freezing temperatures. These variations in thermal patterns are valuable clues for scientists trying to understand what kind of environment exists on the planet. With its infrared imaging capabilities, the James Webb Telescope is able to study Proxima b's heat emissions, offering essential data about its atmospheric makeup. Interestingly, the telescope's orbit around Earth happens to align well with Proxima b's orbital cycle, giving scientists an opportunity to observe its day-night transitions every 11.2 Earth days. If the planet does have an atmosphere, the next step will be to analyze its chemical components, searching for indicators of life, such as oxygen, water vapor, or methane. Though the James Webb Telescope excels at analyzing certain atmospheric gases like water vapor, carbon dioxide, and methane, it has limitations in detecting free oxygen, a critical indicator of life. However, it can still look for related signs like ozone, which can also point to a habitable environment. As scientists dig deeper into the data, the search for life on other planets continues, bringing us incrementally closer to answering the age-old question, are we alone in the universe? That said, the telescope can only closely study a limited number of nearby exoplanets. For more detailed analysis, astronomers are turning to upcoming ground-based facilities like the Extremely Large Telescope, ELT, expected to be operational by 2028. The ELT is designed to deliver much sharper and more comprehensive views of exoplanet atmospheres, offering insights that the current generation of space telescopes can't fully provide. In the meantime, the James Webb Space Telescope remains one of our best tools for studying distant worlds. Despite its limitations, it continues to send back crucial information that helps reshape our understanding of what may exist beyond our solar system. Looking ahead, researchers are also working on future telescope technologies designed to overcome the challenges of starlight. One of the primary obstacles in studying exoplanets is that stars shine so brightly that they overpower the faint light reflected by surrounding planets. To get around this, scientists are developing methods to block out the star's light, much like using a hand to block sunlight so you can see better. One promising solution is the coronagraph, a device placed inside telescopes to block direct starlight, while allowing light from planets to pass through. By reshaping the light waves, coronagraphs reduce glare and make the faint glow from exoplanets easier to detect. Another innovative concept is the star shade, a massive flower-shaped spacecraft that flies tens of thousands of kilometers in front of the telescope. By physically blocking the starlight before it even reaches the telescope, the starshade allows only the light from planets to be seen. This could be especially effective for studying planets in the habitable zones of their stars, regions where water and possibly life could exist. These advanced technologies require an extraordinary degree of precision. For example, aligning a starshade correctly involves maintaining accuracy down to tiny fractions of a millimeter over huge distances. And that's not the only challenge. These systems must also be energy efficient, compact enough to launch into space, and resilient enough to endure the extreme conditions of space travel. If successful, these technologies could allow us to identify biosignatures, chemical signs of life on distant planets. The presence of specific molecules like oxygen, methane, or water vapor in certain ratios could suggest the existence of biological activity. Scientists are also working toward directly imaging these far-off worlds in more detail. Future telescopes may include adaptive optics that adjust for distortions caused by Earth's atmosphere or the movement of the telescope itself. Combined with light-blocking technologies, these advancements could make it possible not only to detect exoplanets, but also to map their surfaces and understand their climates. Developing the next generation of space telescopes marks a giant leap in our quest to answer one of humanity's most enduring mysteries, whether we are alone in the universe. As our ability to observe distant worlds improves, so too does our chance of discovering life beyond Earth, an achievement that could fundamentally change how we see ourselves and our place in the cosmos.